This is ICP-6 and this is Kavin Kumar. So ICP-6 is about creating the k-means clustering on the dataset provided. So we use Jupyter Notebook to do the Python operations. So the first one is about creating the libraries. So we have used Pandas library to interact with the CSV files because Pandas data frames are easy to do operations on the CSV file, where it is CSV files are converted to Pandas data frames. And the next sklearn, where sklearn we have used to get the machine learning models like k-means, PCA, etc., and matplot library to plot the graphs, and other libraries for other operations. And first one is to import the dataset. So if we look into the dataset, we could see the columns like customer ID, balance frequency, and our target is going to be the tenure. So the first one is to remove any null values and replace them by the mean values. So before that, if we count the labels in the target column with tenure, we could see with 10 there are 7,584 data points and 365 data points with 11, etc. Now counting the number of null values in the tenure or in the data set, we could see the null count. The minimum payment has 330 null values and credit limit has 1 null value. So what we did is replace the null values with the mean value. Now if we again count the number of null values in the features, we could see everything is 0 because all the null values are replaced by the mean. Now if print the data shape, so the data shape has now 8950 data points in 16 columns and 8950 with 1 column. This is going to be our target and this is going to be our features. Now in order, the second one is to fit the k-means algorithm on the dataset using, and for the k-means algorithm we need to know the number of clusters. So first, what is the k-means algorithm? So if we have a unclustered data, we cluster them by finding the distance between the data points or the similarity between the data points, like this. So we have used the elbow method. In this elbow method, we have iterated between 1 to 7, that is number of clusters from 1 to number of clusters to 7, and found and plotted the graph. So in the graph we could see the highest WCSS value is got on when number of cluster is 1, because all the data points belong to one cluster. Then we see this, and so the number of clusters, if it is 3, if it is 2, if it is 3, it's going on decreasing. So we will take number of clusters equal to 3 and fit the data points and make the prediction on the Y column and print the score. So in order to print the score, we have used silhouette score. So our silhouette value is a measure of how similar an object is to its own cluster compared to the other clusters, and its values between -1 to +1. So we could see silhouette refers to a method of interpretation and validation of consistency within the clusters of data, and it is calculated by, let's say we have a data point, we calculate how it is good within its cluster. So we got about 0.46, which is 46%. Related score gave us 46% accurate. Next, going to the principal component analysis. So if you apply principal components on our data set, before that, what is principal component analysis? Principal component analysis is a statistical procedure to do the orthogonal transformation. For example, if this is our original data set, we could set our new axis as the x-axis and y-axis on a center of the data point like this, so that it will be easy for us to make a prediction or fit a machine learning model. So we use standard scalar and fit the data points and PCA on 3. So we could now see it ranges between -1 to +1 on the data columns 0, 1, 2. Now if you apply the selected score using the same number of clusters, we could see the score is about 38%, but before we got 46%, because now after applying the principal component analysis, the score has decreased. So sometimes even applying the principal component analysis, the score might decrease. So that's the end of ICP-6. Thank you.